Hey, good morning, everyone. Good afternoon, good evening. Here we go. We're going to be starting Chapter 8.1, Radical Expressions and Graphs. This should get pretty nerdy, but we will turn that nerdy into awesomeness. So here we go. Let's just get crack-a-lack in here. Okay, so we're going to start off by finding the roots of numbers. And before we specifically talk about that, we have to actually talk about a prerequisite, which are square numbers. And square numbers, you probably have seen before, is numbers that you square. So if I take the number 1 and if I square it, if I square 1, the square means I take our base number, this number right here is called our base number, and I multiply it by itself 2 times. So that means 1 times 1 equals 2, which is not true. That's actually going to be 1. Okay, I think I could do this, you guys. Let me try that again there. All right. It's kind of early in the morning here. 1. Okay. And then these things keep going, right? If we do 2 squared means 2 times 2, which is 4. And 3 squared means 3 times 3, which is 9. And these things keep going. We can go all day like it's cool. Well, we'll maybe go up to like 10, and then we'll stop there. So 4 squared means 4 times 4, or 16. 5 squared means 5 times 5, or 25. 6 squared is 6 times 6, or 36. Again, so this number right here, we call that our base number. And we call this little guy right here our exponent. Our exponent. Or it's also known as our power. So just a little nerdiness right there. You know, sometimes I'll say, okay, now take the base number. So I'm referring to this the bigger guy right here. And this little dude is called the exponent, or the power. All right. Let's write a few more here. 7 squared is a 49, because that's 7 times 7. 8 squared is 8 times 8, 64. 9 squared, 9 times 9, 81. And we'll stop at 10 squared, which is 100. All right, cool. So we have 1 through 10 squared. Okay, so this is stuff that we have to know before we actually do roots. All right, so what the heck is a root? Okay, so check out this notation right here. If I said the square root, okay, the square root of 4, okay, the square root of 4 is very similar to doing a square. Notice that it has the word square in there, but so check this out. The way that we do the square root of 4, okay, is this is how you do this. You're asking yourself, what number squared is 4? That's what this means right here. Okay? When I do the square root of 4, it means what number, this blank right here, we have to figure that out. What number squared is 4? Well, look over here, look! We got 2 squared, right? So that's why we could put a 2 right here. So that means the square root of 4 is 2. Okay, if you're like, oh, I don't know about that, dude. Okay, well, let's do another one here. Say if I said the square root of 64. Okay, so the square root of 64 means what squared is 64. Okay, that's what this means. That's what it's asking you. Well, look, if we wrote these down over here, 8, right? So 8 squared is 64. So that's why we would put an 8 right here. Okay, I think you kind of get it right there. So that's what it means to take the root of a number. So here we go. I have some examples from our textbook here. I put the nerdy definition. This and nerdiness, just I allude to that, meaning that it's very mathematically written, and I try to simplify it down to where you can understand it. So if you want to check this guy out, it's the exact same thing that we just did, and I'll just kind of show you right now. Remember how we did the square root of 4 equals 2? Okay. Well, see how they put a number right here, n, right? See, when I say square root, that means that there's a 2 right here. All right, and so that means, right, if you check this out right here, b to the power of n equals a, right? Well, if our b is the last number, 2, so it's right here, b and b, okay? So 2 to the power of 2 equals 4. And if you just kind of see how the n is this number and the a is that number, sometimes that can be confusing, that's why, but if you understood what I did on last slide, you're going to be like, oh, dude, I got this, so, or if this is nerdified, then all well for that. But here we go. Let's do these examples down here. And just to let you guys know, this, when it says example 1, this will correlate with example 1 in the textbook. Now, I'm not doing the exact example 1, so that means you'll have the example 1 in the textbook, but then you'll have my example one, which will be very similar. So that means you're going to have a grip of examples that you can be looking at. You have the ones in the textbook, you got my examples, and then of course when you go to the My Math Lab, they're going to have plenty of examples in there as well. So you have a lot of resources here. All right, so let's go ahead and do these guys here now. All right, so what about this now? Now, see how this one has a 3. So instead of us saying the square root of 27, we're going to say this is the third root. Okay, this little 3 right here means this is the third root of 27. So the way that you do this is we say what to the power of 3 is 27. So it's the same process as we did, except now instead of doing a 2, it's not a square root, it's a third root. So what to the power of 3 is 27? Interesting. Well, let's just start with 2. Let's just see if we thought it was 2. Let me change my color here so we're not getting confused with my writing there. Okay, so say we thought it was 2. So 2 is 2 times 2 times 2. Is that 27? Right? Because I'm trying to, if I plug in 2 here, 2 to the power of 3 means 2 times 2 times 2. Well, 2 times 2 is 4 times 2 is 8. So no, it's not 2. Well, let's try 3. Is 3 times 3 27? 3 times 3 is 9. Times 3 is 27. Yeah, we got it. So the answer here would be 3. Okay, because 3 to the power of 3 is 27. Okay? Okay, let's go here to part B. The third root of 216. Whoa, dang, dude. I thought we weren't going to go bigger than 100, man. Well, what's up? What's up? Hey, guys, well, we got to do this all the time. Sometimes we get some big crunchy numbers, but we got this. We got this. The third root of 216 means what to the power of 3 is 216? What to the power of 3 is 216? So we have to do what times what times what is 216. So we know it's not going to be 3 because it's 27. Let's try 4. 4 times 4 times 4. And by the way, if you have a calculator, dude, you guys can just quickly, put 3 times 3 times 3, 4 times 4 times 4. No, you could do that as well instead of doing this all by hand, okay? So 4 times 4 is 16 times 4 is 64. Yep, so not big enough there. If you do 5 times 5 times 5, that's going to be 125. But if you plug in 6 to the power of 3, 6 times 6 times 6, don't think about the book of Revelation right there, but something like that there. So 6 times 6 is 36, times 6 is 216. So 6 cubed, which means that this is going to be 6 then. Okay? Coming over here. Oh, dang! We got a foe in the house. Oh, except I don't want that right there. So check this out. We have a foe. So that means now we're going to take the fourth root of 256. The fourth roots. All right, so the way that we're going to do the fourth root is we're going to say what to the power of foe is 256. Okay, what to the power of 4 is 256. So maybe try 2. Is 2 times 2 times 2 times 2, is that 256? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. No, mijo. So it's not that. All right, well, we could try 3, we could try 4. Okay, so after trying a few numbers there, the actual answer is going to be 4 then. Because if I do 4 to the power of 4, I get 256. I think you kind of see how this works here. So this guy right here, the fifth root of 243 is going to be 3. Why is that? Well, the reason is because 3 to the power of 5 is 243. That's how you check it, If I'm saying the answer is 3, then I say 3 to the power of what? Or 3 to the power of 5 is going to be 243. Okay, and then we get down here to some fractions. Not fractions. Yes, fractions. Hey, guys, we got this, though. Check this out. Okay. So this means the fourth root of the square root, the fourth root of 16 over 18. Meaning, what to the power of 4 is 16 over 18. Okay, now there's going to be a fraction in here, right? So what? So watch. This is how this works here. Let's just look at the numerator right now. Okay. And let me just get my little highlighter tool. Okay, so see how this is a 16 right here? So what number right here do I raise to the power 4 that's going to give me 16? What to the power 4 is 16? Well, isn't that going to be 2, right? And let me try that again there. It's going to be 2. 2 to the power 4 is 16 because 2 times 2 times 2 times 2 is 16. So now we just got the top number of our fraction. And the bottom, what to the power of 4 is going to give us 18? 18. Hold on real quick, guys. Hold on. Actually, that's supposed to be 81 when I wrote that problem here. Yeah, that's actually not impossible to get 18. So I was like, wait a minute, what's going on there? So yeah, this should actually be 81. Oops, 81. All right. So now let's go back to the bottom number now, our denominator. What to the power 4 is 81? And that guy's going to be 3. And there we go. We have the answer right here. It's 2/3 to the power of 4 is 16 over 81. So the answer is 2/3. And then if you want to get even crunchier, check this guy out. We have the third root of 0.064. Man, you're killing me, dude. We put fractions. Now we got decimals. Dang. We got this, y'all. We got this. Okay, so if it's kind of hard to think about the whole decimal thing, let's just ignore the decimal right now. So let's just do the third root of 64. Let's just do that first, and then we'll just move the decimal place over. It's kind of cool right there. So the third root of 64 is 4, right? Because 4 times 4 times 4 is 64. Okay, but we can't say that the answer is 4 because we're trying to get the third root of 0.064. So watch this. Bing! 0.4. Well, okay, this is going to be 4, but this answer is going to be 0.4. Just move the decimal over once, and you're like, no way, dude. What? Is that easy? Watch. I mean, get your calculator and do 0.4 times 0.4 times 0.4. And you're going to get 0.064. Cool beans. So the trick is just do it without the decimal, and then just move the decimal over once, and then you should be good to go right there.